Are you?
All right. Hi, everybody.
Hey, yo.
We're going to get this show on the road. Here's the plan. We're going to do the other half of 7.3, talking about measures of spread. After that, we'll do some of the in-class examples from 7.3. And then talk a little bit about the IA. You get your first little dose of an assignment in relation to that today. That's our plan. Here we go. Let's rock it and roll it here. There we go. All right. So what we're going to talk about today are measures of dispersion, aka spread. So some of these we've already talked about a little bit. The first one being the range. How do we calculate the range for a data set? Yeah, highest minus the lowest. Now the highest value and lowest value have special names. They're Q0 and Q4. High. But that's the gist of it, right? Now, for practical purposes, how are we going to find the highest and lowest values? How would I do it? I would type that stuff in my calculator and run the one variable stats to get the min and max out of it. Because the last thing I want to do is look through a data set that's got like 50 things in it and try to find out what's the biggest and smallest. Like, forget that noise. I'm probably going to need to do some other statistics on it anyways. I'm entering all that stuff in my calculator and pressing enter. Another measure of dispersion related to the range is called the IQR. The IQR stands for interquartile range. To calculate an interquartile range, we need the other quartiles. So again, we'd find Q1 and Q3 and look at the difference of those. How would I find Q1 and Q3 in practical purposes? Use my calculator, one variable stats. I am not doing that by hand unless I have like literally 5 data points. I would consider doing that by hand because it's literally Q0, Q1, Q2, Q. I just got to write them in order, and there they are. But any bigger than that, I'm going to let the calculator handle it. You guys okay? So the IQR is actually super helpful. We can do something with it. We'll talk about that in a moment. Let's do an example of finding the IQR. So here's a data set. I have 20 values in it. So to find the IQR by hand, I'd have to write it in order. Yuck. I'd have to find the middle 2 values, that's the 20 and 25 for the median, and then find the middle between 5 and 20, and the middle between 25 and 85. So there's 2 middle values each there that I would average to find the Q1 and Q3. Or really, realistically, what would I do? Type it into my calculator and ask it to do the one variable stats and just read the values from my calculator. I'm not going to do this by hand, particularly in like a test situation. Like, no, thank you, not doing it. What's the matter?
It's very hot in here.
It's because you've been running back and forth between the bathroom and tripping over desks and banging into things. And...
No, it was really hot last hour.
Everybody's okay with the IQR calculation? The calculator won't do that for you, but it'll find the Q3 and the Q1, and like, for God's sakes, you can subtract 2 things. The useful piece about the IQR is we can use it as a test for outliers. So now we have a numerical test to check to see if a number is an outlier. So our IQR rule is if the measurement is 1.5 times the IQR below Q1, or 1.5 times the IQR above Q3, then those things would be outliers. So in the previous example with the commute times for New Yorkers, we found Q3 was 42.5 and Q1 was 15, and the IQR was 27.5. So if I do 1.5 times the IQR, I get 41.25. So Q1 minus 1.5 times the IQR is negative 26.25. I have no negative commute times on my list, so there's no outliers in the small direction. If I do Q3 plus 1.5 times IQR, I get 83.75. If I go back and I look at my list of data, I had one commuter that took 85 minutes. He would be or I should say, they would be an outlier. Is everybody good with that? Will you have to do this on the test? Definitely. Definitely have to use the 1.5 times IQR test to check for outliers in a data set. And then note any outliers. That is a 100% certainty that you will have to do that again. So you need to be able to do that. Again, not hard, just have to remember what to do, right? The actual doing of it, pretty easy. Remembering the rule, not bad, but like it's not nothing. Okay. Moving on. When we use the phrase 5-number summary, what are we asking for there? It's just the quartiles. Guess where I'm going to get that information from? I'm going to type the data set in my calculator and press enter and just read it off my calculator. Right? I am not doing any of that trash by hand. Nor should you, right? Nor should you. So again, the 5-number summary or 5-figure statistic is just the Q0, Q1, Q2, Q3, Q4. A new type of graph that's related to that 5-number summary is called a box plot or box and whisker plot. You may see it named either way. To do that, you're going to draw a number line. So just like a number line containing x values. You're going to draw a rectangle that starts at the value for Q1 and ends at the value for Q3. Inside that rectangle, you're going to draw a line that marks the median. And then you're going to draw the whiskers. You're going to draw a line from the end of that rectangle to the max or min. Unless the max or min are outliers, then you'll go just to the first or the farthest non-outlier. And we'll mark the outliers with like an asterisk or a star or something. Guess what? Calculator can draw this for us. Can't do the outlier part, but it can draw the rest of it for us. We'll show you how to do that in a little bit. Everybody good? So let's look at an example here of me making a box plot. So again, first thing I do is I find my 5-number summary. How did I do that? Not the way it shows up here. What did I do? Typed it into my calculator and did the 1-variable stats for it, right? So I'm going to draw a number line. I'm going to draw a box, a rectangle that starts at Q1, so it starts at 15, and ends at Q3, so 42.5, and then there's a line at the median, so 22.5. Everybody look good so far? I'm then going to draw my whiskers. So the first whisker goes to the minimum, which is 5. The second whisker is going to go to 65 because we found in the previous example that 85 was an outlier, which I guess I marked with a circle here because getting an asterisk in this plot was becoming problematic, so I just used a different symbol. Does everybody feel okay on making one of these things? Real easy, right, to do. You don't really even need your calculator to do it, but the calculator can, and I'll show you how to do that in a little bit. So far, so good? All right. A second measure of dispersion is called the standard deviation. So we'll show you how to do that calculation, what it means. So let's say we have this following data set. So this is the number of pets owned by students. I don't know who's got 9 pets, but that's like, must be living on a farm or something. And then my question is it really a pet or is it food? You know? Okay, and it was supposed to be a joke and nobody laughed, that's fine. So to calculate the standard deviation, first thing I need is to calculate the mean. And then I need to calculate a deviation for each observation. So that means I'm just going to take the observation and subtract the mean from it. So for this particular example, the mean was 5. You can just take my word on that. If you wanted to do it yourself, what would you do? I'd type in 1, 3, 4, 4, 4, 5, 7, 8, 9 into a list and just do the one variable stat, right? Or you could do it by hand on your calculator. That's not terrible, but like 9 things is still pushing it for me. No, thank you. So for example, the deviation from the first observation, the number 1 minus the mean is 1 minus 5, or negative 4. Is it okay to have negative deviation? Yes, you will. And another deviation, what if I take the observation 8? Well, 8 minus the mean is 3. Is it okay to have positive deviations? Yes. So let's say I did that for every data point.
There.
So you notice in the X column here of this chart, I have all the different data points listed. So 1 pet, 3 pet, 4 pet, 4 pet, 4 pet, 5 pet, 7 pet, 8 pet, 9 pet. Notice those corresponds to the dots on my dot plot. I then did the deviation for each of them. Remember, the mean was 5, so I did 1 minus 5, 3 minus 5, 4 minus 5, 4 minus 5, 4 minus 5, and so on and so forth, and filled that chart up. Everybody's okay? On the quiz or test, I may ask you to show your work for finding a standard deviation. Would include filling out a chart like this. Again, the titles will tell you what to do, right? Xi minus mean. Now we square each deviation after we found the deviations. So negative 4 squared, 4 squared, 1 squared, negative 1 squared, negative 1 squared, etc. So I get all the deviations squared. Everybody's cool? And then I'm going to add up all the deviation squareds and divide by the number of observations, which in this case is 9. There's 9 students, it said in the original. So I'd add up the deviation squared column and divide by 9. That number is called the variance. If I then square root that number, I would get what's called the standard deviation. So what the standard deviation is saying is that on average, a randomly selected individual would be 2.4 pets from the mean. It's the average distance from the mean for an observation, or you'd expect it to be from the population you're studying, right? Everybody's good? So in this case, if we randomly selected an individual, we'd expect them to have 5 pets plus or minus 2.4, right? So as many as 7.4 pets and as few as 2.6 pets. Does that feel okay to everybody? All right, the symbol we use for the standard deviation is that lowercase Greek letter sigma. That's that little O-looking thing there. Now, we just discussed how to do this by hand, right? This is the formula we just did with the columns. Now, this is me writing it in fancy sigma notations. Are we going to, unless instructed to, do this by hand? No. How are we going to do it? The calculator is going to do it for us. When we are asked to do it by hand, are we going to check it with our calculator? Oh, you betcha, right? One thing worth pointing out is that there's actually 2 different types of standard deviation. In this class, we're only going to talk about population standard deviation. There's also a sample standard deviation. Your calculator has both of them as outputs, so it'll be important that we know which one is which. The only difference is the sample standard deviation, instead of dividing by n, we divide by n minus 1. That's the gist. Everybody okay? All right. So at this point, we have 2 different common measures for, well, the DMV says that I have outstanding traffic tickets.
Scam.
It's a scam. I know, because I haven't been pulled over in like 2 years, so I don't know where I'm getting traffic tickets from. So we have 2 measures of commonly used measures of center, mean and median. We have 2 commonly used measures of dispersion, standard deviation and interquartile range. You should remember that standard deviation goes with the mean, because what do we need in order to calculate the standard deviation? We use the mean in order to do the calculation, right? For the interquartile range, that goes with the median, because what do we need to calculate the interquartile range? The other quartiles, which the median is 1. Everybody okay? So those things go together. The question that we're left with is, when do I use mean and standard deviation, and when should I use median and interquartile range? We're going to answer that question right now. We should use the median and the IQR for a skewed data set or a data set that has the presence of outliers. Skewed or outliers, median, IQRs. If I have a symmetric distribution with no outliers, I should use mean and standard deviation. On the test, when I ask you to do the SOX for a data set, if you say the data set is skewed or has outliers, and you report the center with a mean and the spread with it, or the spread with a standard deviation, you will get a deduction because you're using the wrong measure of center and dispersion for the situation, or vice versa, right? You have a symmetric distribution with no outliers, and you try to use, or you say to use median and IQR. Again, you'll get a deduction. You're using the wrong one for the situation. Is everybody clear on that? So again, something to remember, right? Not really a formula, but like something worth highlighting, making a note to yourself that, like, I promise you Mr. Kulik is going to give me a question like this on the test where I have to make sure I make the right choice to get full marks for a problem. Okay, here we go. Transforming data. let's say that we're going and doing an experiment here and we're making some measurement. We're measuring the lengths of something. Everybody's okay? And we find out that the measuring stick we were using, we're told it was like, it was like 36 inches long, and come to find out, oops, it was broken, it was only 33 inches long. Right? We've done this measurement, we measured something in inches, but all the inches measurements were like off by a factor, off by 3 units or something. We'd already finished all of our statistics. We did our means and our medians and our, everything we figured out. Do we have to start over with all the right measurements? Well, let's think about it this way, right? We have our distribution, looks like this, right? We add 3 to it. We're off by 3, and it moves like here. Did the center move in doing that? Yeah, how much did it move by? Like the 3 that we adjusted. Means and medians, you transform the data by adding or subtracting a constant amount to every single measurement.
Can we take a couple pictures?
Yeah, I was wrong on the day though. It'll be next 7th hour. We're just sitting here talking about stuff.
Yeah, it's fine. What day is it?
Next time we have 7th hour.
Okay,
That's perfect, thank you.
Yeah, I'm sorry.
It's okay.
Tuesday. My apologies, girls. I was off. Oh, I know, right? Your hair didn't look good.
The day before we're marinated.
Oh, okay.
You know what that means?
No.
Marination leave. It's when you look down
So then
Oh.
all up on homecoming, everyone's like, dang.
So it's like you're just like setting
You're like
expectations
marinating
real
in like
low.
ugliness until you can like.
Hi guys.
I'm actually tan.
Ooh.
That was pretty good.
All right. Okay. So if we add or subtract to every value in the data set, the center moves by that same factor. If this was my data set, I add to it. It's now here. Did it spread out any more than it was? No. The spread stayed the same, right? What's that going to tell me about the IQR and standard deviation? That it does not change if we just add something to every value. Everybody's good? What happens if we multiply? Oh, here's my example. There's data set 1 and then transform data set 2. Notice the shape, identical, didn't change, right? The spread, identical, doesn't change. The center, that changed, right? Because the whole thing picked up and moved. Cool? And then here I actually did the numbers so you can see. Okay. What happens if we multiply or divide? So we had a distribution look like this. We multiply everything by 2. Now it's going to look like this. Did the center change? Probably. Yes. Did the spread change? Yes. How much did they change by? Factor of 2 for both of them. So multiplication changes both centers and spreads. Addition, only centers, not spreads. This reeks of a test question. Right? Reeks of a test question. Multiplication affects both. Addition, only centers. Everybody feel good? Multiplying doesn't change the shape though. If you're skewed to start with, you're still skewed. Symmetric to start with, you're still symmetric. Just like spreads it out. So take a look at this data set. This is an example where we multiplied by 3.28 feet. It's converting feet to meters or something, or meters to feet. So notice that it was skewed right to start with, still skewed right. The center changed a little bit, right? and the spreaded outness changed a lot. If I looked at the actual standard deviations, 7.14 changed to 23.43. That's exactly multiplying by 3.28. Everybody's cool? So that's just me showing you numerically that it works. That's it for the notes. Let's do some of these in-class examples and practice doing some of this stuff on our calculator. If you have your calculator with you, I'd invite you to take it out so you can follow along. If you don't have a calculator with you and you want to borrow one, I got some of those Bad Mama Jammas sitting on my desk. You're welcome to help yourself. All right. Our first example says find the 5-number summary for the list above. How would I do this in practical terms? Goes into my calculator. How do I enter data into my calculator? Stat. Edit. I'm going to put mine into L4 because I know that I'm going to need these other lists later on to do something else with, so I'm going to leave them there. So I'm going to just type in my stuff now. I invite you to follow along if you'd like. Good practice, because there's nothing Mr. Kulik hates more than on test day, you acting like you've never used your calculator before. Been like, how do I enter data into my calculator? And I'll be like, what were you doing on the day where we practiced it? So I got all my 16 data points in. I exit out. After I've entered my data, what do I need to do to get my 5-number summary? Stat, calc, 1 variable stats. Now I type my stuff into L4. You guys probably have it in L2 or L1, I'm sorry. No frequency list. Boom. If I just click down. Uh-oh, that's not right. Look, what did I say my minimum was? 30? That can't possibly be right. It should be 340. Oh, Mr. Kulik, should have checked. I know I should have. Yeah, 260 should be the minimum. There. Now I fixed it. Impressed on how fast I reran everything? So I'm a wizard. A math wizard. Katie, what's up? You're okay? Okay. Any questions on how to do that? Get the 5-number summary. Okay. We're skipping example 2 because it was like the same thing as example 1. Example 3. Recognize this data? It's the exact same data. If I want the mean for this, what do I need to do? To just go back up and look at your output from your, from your 1 variable stats. It output the mean with the 5-number summary. For free. Woo! Thanks. It's nice to have it all on one screen, right? All right. Shh. Next up, example 4. Below is a frequency chart for the number of books 30 students in an IB Math SL class had in their book bags. If I want to calculate the mean for this, how do I do that with my calculator? Or I can use 2 lists, right? I can put in L2 the number of books, in L3 the frequencies, and then when I run the 1 variable stats, I'll do X list as L2 and frequency list as L3. And then the mean that'll pop out is that weighted average that Marin was talking about doing by hand, which you can do by hand, not wrong. Will there be a question where this comes up on the test?
Yes.
Gosh, there certainly will be, because you guys still made a mess of it on the quizzes when we did it last time. Still had a lot of people not weighting their averages, just adding up the numbers and dividing by 9 or whatever here. 7. Like, nope, that ain't right. When I have all the quizzes taken, I'll give those back to you. Overall, they were quite good. Okay, I'm not gonna, the answer for this is on the solutions. I just want to talk about it. What do you have to do if I want the mean from something like this, where you're not given specific x values, but rather a range of x values? The mid-interval values, 100%, yes. So we've used the mid-interval values along with the frequency list as our L2 and L3, and just run our one variable stats on that. Now, I want to point out to you guys, ideally, your ranges would be equal size, right? When you make these, should you assume that they're going to be? What did anyone notice on the quiz? That I did not do that? That on the quiz there was one range that was bigger than the other 4? I caught a lot of people missing that. They just did like the first 2 mid-interval values and must have been like, got the pattern, wrote it all the way down, and it's like the last one was different. So I tricked a bunch of you guys. Now, that's not good practice to have the ranges on equal size, but you have to take a look. You can't assume the person doing this is doing a good job. Now here, that is the case, right? Everything is, 5 measurements wide. So it's fine. But, careful. Maybe your teacher's a sneaky jerk and had the last value 6 units wide instead of 5. I think 47.5 was the last one instead of 47. I had lots of 47s. I know, right? Well, you've learned your lesson now. You'll be on the lookout. You did get it right. Well, there you go. Well done. 6 is the same thing. We're going to skip through that. I'm not making stem plots. We've done that a bunch of times. I don't care. We're changing that. I'm not doing any of that. What I will do here real quick is I'll show you how to build a box and whisker plot from that data we just looked at. Okay, so if you're interested, again, not hard to do on your own, right? It's just 5-number summaries, like basically all you need. But if you want, we can do second and then y equals. I'm going to choose one of the plots, say plot 1. I'm going to turn it on. I'm going to pick the box and whisker plot, which is this option here that looks like the box and whisker. And then my data that I did, or that we looked at, I put mine in L4. So I'm going to do that. And now I want to graph this. Now, getting it to graph right is usually the trick. The easiest way to make sure it graphs right is to pick zoom, stat. If I do that, the calculator automatically change my window so that whatever the plot is that I'm making with the statistic just shows up for me. So that's nice. Nice. How do you guys feel? So far, so good? How's your snacks? Oh, yeah, Brody won't eat. Okay. Let's look at the second part. So here we have a list of fat for the 12 different McDonald's sandwiches. I want to know which one is the one with only 9 grams of fat. I'm calling BS on you, Ronald McDonald. What do you think? Maybe it's just the bun. Is that the hamburger hold the burger?
Could be fish.
The fillet of fish, I bet, has the most.
Really?
Yeah, man.
Oh, fish was not very fat.
It's deep fried, though.
Yeah, true.
It's deep fried.
Oh,
Okay, so maybe.
maybe it's big enough.
Well, the Big Mac has that mayonnaise sauce on it. That's got to have a high fat content, too.
Just what about the normal hamburger?
Straight up hamburger, bro.
Yeah.
The 9 is a normal hamburger.
Just one patty, 2 buns, nothing
Yeah,
else.
that's all.
I don't know.
Hamburger.
Yeah, like wheat balls.
No beef bun. I don't think there's a lot of fat content in non-beef bun, so just calories. All right.
Normal ones, like burgers and balls.
So I entered in the data. I notice I still have a mistake though. I'm checking this time, right? That 2 should be a 12. Great googly moogly. Oh no, that 2 was come after the 19. That should have been a 20. What is going on here? Oh my gosh, Mr. Kulik, you've made a complete mess out of this whole thing.
How do you clear them?
You can just type over them
Yeah, but
individually.
say-
Oh, you want to get rid of the whole list?
Yeah, well, just like say you had like less data and you wanted to put it in like element 1. Like, what would you do? Like, say you had like 3 numbers instead of like 25.
Yeah, so if you want to clear the whole list, what the heck did Mr. Kulik, yeah. So this is what you should do. This is what Mr. Kulik's going to do here because he's made a mess out of this whole thing. So you move your cursor up on top of the heading. If you press clear and then down, it wipes the whole thing. If you want to get rid of one individual entry, like say that I typed a 5 here and it just was like I don't even need an entry here, you can press delete and it'll get rid of the single entry. Does that answer all your questions there, Maren? Between those two, you should be able to do what you need to with it.
Got it.
Good, good. Okay, there's everything I need. So then I do my one variable stats. My stuff is in L5 now. Nope, I said L5, not L3. So there's my stuff. To get my IQR, what should I get?
So, what do you guys get?
8. 29 minus 21 is 8. Okay. So if I want then to check if there's outliers, what do I do?
1.5 times 8.
1.5 times 8 is 12. And then what do I do with that 12?
If anything's past that, it like is an outlier, right?
I take the Q1 and subtract 12 from it. So 21 minus 12 is 9. Do I have anything on my list smaller than 9? No. I have 9. Is that smaller though? No. So it's safe. By the skinniest of margins, it is still safe. And then to find the upper outliers, I do 12 plus Q3, which is 12 plus 29 is 41. What does that tell me then? 43 is an outlier. This whole greater than or equal thing is like
Yeah, I just can't read it.
the alligator eats the bigger number.
Yeah.
I'm doing my doctorate in mathematics, and I still think whenever I see the inequality, it's like alligator eats the bigger number. So, all right. So we did that. Okay. So if I wanted the socks for this, if I want the socks for this distribution, what measurement should I be using for my center? Mean or median? Median. Why? If you look at this, it looks pretty symmetric. to be honest with you. You're correct. We should be using median because there's an outlier. Correct. What should I be using for the spread? IQR. So I would say there's a symmetric distribution with one outlier at 43, centered at 26 with the median, with an IQR of 8.
When you're making your documentation class, what dictates how high it is on the Y value?
Nothing. Whatever you feel like.
Oh, okay.
Everybody feel okay? All right. I'm not going to make another box and whisker plot because we already did that on the calculator earlier. And like yuckarooskies. Let's do this though. Says below is a list of numbers for students in 7 different classrooms. Use the data to find the variance and standard deviation for the number of students in the 7 different classrooms. Then interpret the value and context of the students in the classroom. And we're going to show our work doing this. We're going to use our calculator to do that, showing the work. So that table that we showed in the PowerPoint, we're going to build that on our calculator. So I highly suggest, if you have a calculator with you, that you follow along on this part, because this is not obvious where it's like using the same one variable stat over and over and over again to do some stuff. And I promise you we'll have a test question where I ask you to complete a table similar to what we're about to build. Everybody ready? Okay. So step 1 is going to be entering this data. I guess I don't have it where I thought I had all this stuff still entered. I'm going to enter mine in L1. All right. Have you entered your data? Okay. Once I've entered my data, I'm going to exit out of here and I'm going to run the one variable statistic because I need the mean in order to do this. Now, in this case, the mean is a whole number, but I'm going to approach this problem as if that mean was like some kooky long crazy decimal. That's going to be a pain in the butt to deal with. But the way I'm going to do it doesn't matter whether the mean is a nice, neat, round number or some like infinitely long decimal. I'll get the same result. Everybody's good? Okay. I'm going to go back to the stat menu. I'm going to go back to the edit tab and back to the edit command. And what I'm going to do is I'm going to put the deviations now into L2. Now I could do this by hand, right? I could do 25 minus 24, whatever the mean was, and then 22, and type them in. I'm not going to do it that way because I don't trust myself. The formula for a deviation is observation minus mean, right? So what I'm going to do is I'm going to move my cursor so that it's on the title for L2, and I'm going to press enter. And now see at the bottom, oh, I stepped on it, didn't like that. Come back. Oh no. Come on, there we go. See at the bottom now where the L2 is flashing came up. What I'm going to type in is, where are my observations at? They're all in L1. So I'm going to type L1. And then minus, I'm going to type the mean. Now I'm not going to use the number, which I found from my calculator 24. The calculator's actually stored that number into a variable. I'm going to have the calculator call that variable name here. So if that mean was like some long infinite decimal, the calculator's going to use that whole decimal that it has stored and I don't lose any accuracy from rounding. Everybody's okay? To find the variables, the stored variables on my calculator, I press the vars button that's right down there below the down arrow. The type of variable I'm looking for is a statistic. It's the mean. So I'm going to go down to the statistics tab or the statistics option. And the statistic I'm looking for is the mean, which is called X bar on my calculator. And then I press enter. Boop. Populates the whole list for me. So if I had like 1,000 data points, boy, that's a time saver, right? The next column needs to be the deviation squared, right? So I'm going to move my cursor up to the title for L3, press enter. Where do my deviations live? They live in L2, right? That L2 column is my values for all my deviations. So I'm going to do L2. And what am I doing to those deviations? Squaring them. So I'm going to do L2 squared. And then press enter. And it populates that whole list for me. Everybody so far so good? Okay. The next thing I need to do then is calculate the variance using L3. So remember, the variance asked me to add up the whole list and divide by the number of observations, right? So I could do that manually by adding those numbers up and dividing by, was 7 or something. There's 7 of them, I think. Or I can have the calculator do all that stuff for me. So I'm going to exit out of here. And I'm going to do the one variable stats now on that L3, the place where my deviations squared live. So stat, calc, one variable stats on L3. So this sigma x, that's the sum of all the values in that list. I need that. That n down there is the number of things in my list. That's what I want to divide by. So what I'm going to do, I'm not going to type in the numbers from here, because what if they're like kooky long infinite decimals? I'm going to use the stored variables from this. So I'm going to press vars, statistics. I'm going to go over to the sigma command. And there's my sigma x that I'm looking for. And then I'll do divide by vars, statistics, and then the n, that's what I'm looking for, and press enter. Did you recognize this number when it came up when we did the one variable stats on L3 just a minute ago? This was the mean from there also, to show me that you could take that number also. So that's the variance. If that's a question, there it is. Everybody's good? If I want the standard deviation from that, all I have to do is square root that number. So I have 2.32999. Do you recognize that from somewhere? Did we see that number earlier? If you guys remember when we did the one variable stats on the original data on L1, did you see that number anywhere here? Sigma x, that's the standard deviation. So that's your check. The capital SX is the sample standard deviation. That's the one we mentioned that we'll never use in this class. But that's what it is in case you're curious. What do you guys think? It's okay? Okay. All right. blah, 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 blah. I feel like I'm done for now. Let's talk about IA stuff. Oh, I didn't copy it in here. Let's grab it.
Okay, so standard deviation is the little O thing then, yes.
Yes, that's the lowercase Greek letter sigma.
What's the SS?
That's the sample standard deviation.
Okay.
That's a statistic we will never use in this class. So you don't have to worry about it. Unless you're taking another statistics class on the side
I'm not.
and you're cheating on me with another math teacher. Oh my gosh, okay. That's so stupid. That's not the class I want. I'll be right with you guys. I just forgot to copy this folder over. And then when I went to copy it over, I did it wrong. I know, is what I say too. This whole week. You know? There we go. You go away then. All right. So this is now in the content library. If you ever want to look at this, it's there for you to look at. I'm just going to move this a little bit so I can reach the mouse. I'm not taking it from you intentionally. I am, but it's not because you're saying that. Anyways, so the idea. This is too small. Let's make that bigger. Whoop. All right. You're going to choose two quantitative variables and try to determine if those two variables have a cause and effect relationship on each other. That's the gist of the project. The variables you choose are entirely up to you, but they have to be things that are quantitative because we have to be able to do a calculation with them. So like colors don't work. Or like genre of music doesn't work. The relationship you are choosing needs to be unique, which means no two students from this hour or the other hour can choose the same project. Okay? So topics that could be or that have been chosen in the past that are not available to be chosen now, because I'm using them as examples, could be things like how much sleep a person gets versus their GPA. Or the person's GPA versus their overall test or their overall ACT scores. Unavailable topics, they're my example ones. What do you notice about both of those topics? How would you get that information?
Surveying.
You'd have to survey your classmates, right? Do you have to pick a topic that's the data is acquirable via survey?
No.
No.
Online.
You could use a publicly available database of information. That would be fine. In the past, students have done stuff using, sports statistics that usually the professional sports leagues keep a pretty good warehouse of publicly available statistics that you could draw from. Or they've used, like movie reviews and box office or something, which again, these things are pretty publicly available. They're relatively easy to find and use. Or traffic statistics, or crime statistics. Again, these things are relatively easy to find. But you have to, when you're picking your topic, you have to think about how am I going to get this information? I had a student last year write up this lovely proposal about music and plant growth, and I had to ask him, I'm like, Sam, who's going to do this experiment? Are you going to plant 60 plants and play music to some of them and not to the others, and make sure you're watering them every day and checking on them, measuring them, and doing this the whole time? He's like, no. I was like, he's like, okay, I won't do that. I'm gonna pick something else. But you got to think about that as you're coming up with a topic. You can pick that, growing plants and using music or whatever. But then I don't know who's going to if you don't have the data from somebody, you got to do it. And I don't think you probably want to, right? You guys have enough on your plates that you're like, I don't need to have a greenhouse at my home and worry about doing this every day. So my suggestion to you is pick something that's easy to acquire data for. Okay. So in the process of completing this, the actual IA won't be due until like after Thanksgiving break sometime. We have some milestone things along the way that are going to count as quiz points, so quiz grades. Your first quiz grade is going to be your topic proposal. So 20 points, getting your topic approved by me. So the topics are approved and accepted on a first come, first served basis. We'll talk about how that process works for submitting in a second. So again, first come, first served means you want to do it kind of as soon as you can. And you probably want to list more than one option because that's your place in line. If you get rejected and have to pick something else, you're at the bottom of the line now for your second choice. It's easier if you include 2 or 3 options that are decent, that you'd be okay with. And if your first one is gone, or I don't like the second one, you still have a backup in that spot in line. Everybody's okay? So what you need to have in your submissions, you need your variables clearly labeled, independent, dependent variable, and what they are. So for example, when I talk about sleep and grades, was one of the examples. My independent variable would be hours of sleep per night. The effect variable would be the weighted GPA. After that, I have to include a statement about what I want to show. So I said, I will try to show that the number of hours of sleep a person gets per night impacts their overall weighted GPA. I hope to be able to prove that the more sleep a person gets per night increases their overall GPA. Right? So it's a statement of purpose. A couple of sentences. Doesn't have to be like a page. I also need you to include then, this topic is important to me or important to someone, who those someones are, because blank. You have to sell me on why is this project worth doing? Who would benefit? Now, it could be you specifically, but it could be, in the case of like sleep and grades, you could sell that any student would be interested in this, or parent, or teacher, or school administrator, or legislator that's deciding on school start times, or the length of the school day, or the number of school days. This is where you get out your BS skills, and like you sell me as to why this is important and why this is worth doing. Okay? You get as grandiose as you can, within reason, right? But that's what we're looking for here. Does everybody understand what I'm buying? And that's actually part of, like, that's a criteria in the IA grading, is how well your personal engagement. So like how well you can sell the importance of this and your process for like doing this. So like selling it up front is a part of that. Okay. So to do the submission then, you've found out what needs to be in it. You look at this form. Email to me. Your title should be period. I have 3 hashes there. What is period are we in? 7, so you put a 7 there. IB, Math, SL, IA, Part 1. You should have either directly in the body of the email, the stuff we discussed. In a Word document attached to it, what we discussed. A Google Doc with permissions allowed for me attached to it. Nothing will be accepted verbally or handwritten. Why do I need it via email? The timestamp for first come, first serve, right? Has to be emailed. You want to talk to me like, hey, is this a good idea? Like, what do you think about? Happy to have those conversations. Somebody takes your topic beforehand, not my fault. Okay? Way you can get deductions late, or you've submitted, I approve, but you're missing information. As long as you're before the due date for this part, if something's missing, you can fix it. And I'll rescore it or whatever, I'll let you know. Is everybody okay? Let's say due date wise, nothing next week. Let's have it the first class after next weekend. So this is so that'd be a Monday for you guys. Does that feel okay?
Yeah.
Actually, let's make it Wednesday, because that's the A day will come. They'll be due on Tuesday, so it'll be like the Wednesday then. So it's like approximately the same amount of time. Okay?
Yeah.
Does everybody feel clear as to what you need to do first?
Yeah.
Cool. So, what's up? Oh.
Yeah.
So think about your job over the weekend. You don't have to do anything, but you should be thinking about, like, what would I be interested in doing? What could I do? What sounds neat? You know, like, what kind of stuff am I interested in general in life that I think that there's a relationship on that I could get invested in? And sometimes it's about just like getting it done too. Like some of us are like, I don't care about anything. It's like, well, then just find something that you don't care about that you can complete the assignment for. I think we're probably at the end here.
What if we already know our topic?
Then you should write it up and email it.
What do we have on the word down?
The independent, dependent variables, your statement of purpose, why it matters.
Oh, we don't just tell you our topic?
Correct.
Just doing part one.
Just doing part one. Hey, we have 10 minutes still, dudes.
Or reset class.
So,
Says we finish at 11:45.
In that email for our topics, do we have like multiple topics with multiple variables on
Yes.
that Word document?
Yes, each one of them needs their own statement of purpose and selling me as to why it's important. But you can submit more than one thing. We'll rank them in order that you want them. But if one is unavailable or inappropriate, I'll look at the next one and the next one until I find one that's good. Yeah.
Yeah. I can do something.